Hello everyone, I am Pragati from ISC department. Today we are all going to present on machine learning algorithm. Our teammates are Dikshita, Siri, Tejaswini. Our topic is decision trees and linear regression for regression tasks and the experiment decision trees and linear regression to predict the house prices, a common real world problem with a significant implications in the real estate and investment sector. I will explain the first part of the code where we import the necessary libraries and load the dataset. I'll share the I'll explain the first part of the code where we import necessary libraries and load the dataset. NumPy, NP for numerical operations, Pandas PD for handling the data efficiently, Mat, O, Matplotlib and Sebron for data visualization, Skitlearn for model building and data preprocessing and evaluation. From sklearn datasets, import fetch California housing data is equal to fetch California housing. We then load the California housing dataset using the California housing, which contains the housing price data. DF is equal to PD data format data columns, which is equal to data feature names. We convert the data into the pandas data frame and add a new column price, which is our target variable prices. Finally, we display the first few rows of the data set to understand the structure of the data. For the example, think of this data set like an Excel sheet where each row represents a house and each column represents a features like the number of rooms, population, and location. The last column price is we are trying to predict. Then further part will be continued by Siri.
Next one is splitting data and standardization. Now that we have our data set ready, I'll explain how we split it into training and testing sets and standardize the data. X is equal to df dot drop, columns is equal to price, y is equal to df of price. We separate the data set into X, which contains all the features as input variables, y which contains the target variable as price, x train x test, y train y test is equal to train test, split of x y test size is equal to 0.3, random state is equal to 42. We split the data into 70% training and 30% testing. The training data is used to train the model and the test data helps us evaluate its performance. Scalar is equal to standard scalar of x train is equal to scalar dot fit transform of x train. X test is equal to scalar dot transform of x test. Since the values in different columns have different scales, some are in thousands, some in decimals, we use standard scalar to bring all values to the same scale. This improves model performance. Example explanation. Imagine different runners in a race. Some start ahead and some start behind. Standardization ensures that everyone starts at the same point, making it fair for all features. Next will be continued by Dikshita.
I am Dikshita from ISC department. Now I will explain how we train two machine learning models in making a production. IR model is equals to linear registration. IR model dot FIT X train Y train. IR PRED is equals to IR model predict X set. We can create a linear registration model, train it is used fit and make a prediction, and on the test set using predict linear registration find the best fit line to predict our price. DT model is equals to decision tree regression, random state 42. DT model F fit X train Y train. DT predict is equals to DT model dot predict X sheet. We then create a decision tree model, train it in a same same way and take a prediction. A decision tree works like a flowchart, splitting a data at each step to reach a prediction. Example explanation. Linear regression is like drawing a straight line through a sector plot, estimates trends, while decision tree are like a series or yes or no question to split a data into smaller section to better prediction. Next will be continued by Tejaswini.
For model evaluation and visualization, I'll explain how we evaluate our models and visualize the results. We calculate two important error matrices for both models, MSE and MAE. MSE is mean squared error, measures how far of the predictions are penalizing larger errors, and MAE is mean absolute error, measures the average error without squaring it. Print model performance and print linear regression. We print the MSE and MAE for both models to compare their performance. Models is equal to linear regression decision tree. We store model names and their error values for visualization. We use bar charts to visually compare MSE and MAE for both models. This helps us quickly see which model performs better. Example, MSE is like a total penalty for incorrect guesses, while MAE tells us the average amount we are wrong by. Lower values mean better predictions. The bar chart make it easier to compare models visually. This is the code explanation, and the output will be explained by Pragati.
The output of this code is there is a dataset samples and longitude price. For the model performance linear regression, MSE value is 0.5306, MAE value is 0.5272. For the decision tree we get a value for MSE is 0.5273 and MAE is 0.4687. For IPython input, we have to input the two for the linear regression and decision tree, which is shown in this figure for MSc and MAE. Thank you.